So to add on to the video that you just watched, I'm going to walk through a few examples that will hopefully help you to apply SOHCAHTOA and the information about reciprocal trig ratios. But the first thing I want to point out is that in your NESA reference sheet on the second page, towards the top left-hand side, you'll see this screenshot that is on the left-hand side of my screen is also the same thing that you'll find on the reference sheet. And you're welcome to use it, but hopefully as an extension student you won't need it. So the first example is when you're given a trig ratio. Say for instance here I'm given that the tan theta is equal to 3 on 11. I'm asked to find the exact values of sine theta and cosine theta. I don't actually have to calculate that angle measurement. I just need to recognize that in a right triangle, where I call this angle right there theta, that because I have tan theta equals 3 on 11, they're telling me in that ratio that my opposite side from your angle is 3, your adjacent side is 11, and using Pythagoras, I can find my hypotenuse. So x squared equals 3 squared plus 11 squared. So x squared equals 9 plus 121, which is 130. And then x is the square root of 130. Now I'm pretty sure that that's in simplest radical form. If it wasn't in simplest radical form, you'd need to put it in simplest surd form. And that's what they mean by exact values. You don't actually need to calculate the decimal equivalent of the square root of 130. You just simply use, okay, I want the sine theta, which is my opposite side to theta, which is 3, on my hypotenuse, which I just found was the square root of 130. And it's done. And that's exact values. And I didn't touch my calculator. Cosine of theta is the adjacent side to theta, which is 11, on my hypotenuse, which is the square root of 130. And that is all they want. And perhaps I might have needed to touch my calculator to calculate 3 squared and 11 squared and adding them together, but you're not meant to calculate the square root of something if it isn't a perfect squared number. So that's the beginning of the examples. And then if you have a look at page 14 of your booklet, you're asked to determine the ratios for cosecant and for cotangent if you know that the secant of theta is 4.5. And this is a little sneaky one. That is a ratio. You could use your calculator or simply the knowledge of how to change that back into an improper fraction. That's 9 on 2. And they've given you sides again. So just like the video previously just said, that secant, the third letter is C, so this relates to the cosine of theta. It's just the reciprocal of cosine of theta. So since cosine is adjacent on hypotenuse, the reciprocal of that means the 9 is your hypotenuse and your adjacent is 2. And once you know this, then you can go about doing the exact same thing that we did on the previous example, generate what your opposite side is, and then determine the ratios for cosecant and cotangent. So that should give you a pretty good background as to how to start example 2.3 on page 14. You may want to pause the video now and catch up with completing page 13 and page 14 of your booklet. Welcome back if you actually did pause. If you look at page 17, you'll see that we're asked to complete a table of values. What they're asking for is to fill in the ratios. And you can see I've already written down the first row, which is asking for sine of theta with 30 degrees, 45 degrees, and 60 degrees. At the top of page 17, you also have the two triangles that you will also have available to you in every test you will ever sit. So on your reference sheet, notice you have these same two triangles, 45, 45, 90, and 30, 60, 90 on your reference sheet. And what they're asking for is simply what is the ratio of sine, so that's opposite on hypotenuse when we look at the 30 degree angle. So if I look at my triangle given to me, 30 degrees, opposite to that is 1, on your hypotenuse is 2. And that's all they're asking for. For 45 degrees, go to the 45, 45, 90 triangle. Opposite either one of the 45 degree angles is 1. On hypotenuse is root 2. And then do it again for 60. Find your angle that is 60. Opposite that is root 3. On your hypotenuse is 2. And these ratios never ever get expressed as decimals. So I don't want to see anything but root 3 on 2. I don't want to see 0.866 or anything of that matter in this ratio. They need to be exact values. They should have actually said exact values in the instructions. So you may want to pause and complete the table on page 17 at this time. And last but not least are 2 more examples finding missing sides or missing angles. So this will help you to complete example 2.8 and 2.9 on page 18 and page 19. So depending on where your angle is, you need to determine what sides are given or asked for. So given that we've got the 63 degree angle, the side that is 5 is adjacent to that, and x is my hypotenuse. This tells me that I need to be using cosine of 63, because then I can put this in the ratio of your adjacent on your hypotenuse. And then I just need to solve for x. So I'm going to multiply both sides by x. Cosine of 63 degrees on the left-hand side. And when I multiply the right-hand side by x, the x cancels out on the denominator, and I get 5. One more step, divide by cosine of 63, which is just a very, very ugly number. And at this point in time, if you haven't already read what I said earlier in the discussion and the assignment, you need to make sure that your calculator is in degree mode, because this is the cosine of 63 degrees, not 63 radians. And so when you calculate 5 divided by cosine of 63 degrees, you should get 11.01, and that's rounded to 2 decimal places. If you're in radian mode, you'll get something very different. So although you might have done all of the correct steps, you'll still get the incorrect answer if you're in radian mode. And then example B is finding the missing angle, and it's pretty much the same thing. You need to look at what you've got. The angle is identified by theta. The side that is 2 is opposite the theta. The side that is 11 is adjacent. And so that tells me that I'm going to be using tangent of the angle, theta, and it's opposite over adjacent. And to find your missing angle, that's where inverse tan gets used, or if I had sine, inverse sine, or if I had cosine, inverse cosine. On your calculator, it's the tan -1, which you have to hit the second button first to be able to access inverse tan of 2 divided by 11. And again, you need to be in degree mode, and when you do so, when you calculate inverse tan, or tan -1 of 11 on, or sorry, 2 on 11, you'll get 10.3 degrees, and that's rounded to 1 decimal place. And hopefully this gives you enough explanation that you can now complete